Okay, we're going to discuss some of the things in this section of the modules briefly, just to highlight some things that are important. Okay, so with flow, we want to think of it as Q, because Q is going to be used in Poiseuille's equation and a couple other things. So always associate flow with the letter Q. So flow is going to be the volume in time. We'll cover that a little more later. Energy is our ability to do work, and a system will never lose energy. It's just converted from one form to another. In the circulatory system, the important things are potential and kinetic energy. Kinetic energy is the energy of motion, so as the blood is flowing, moving through tissue, that is kinetic energy. The pressure is what we usually associate as being the potential energy of a system. So in a vascular system, the movement is kinetic and the pressure is the potential energy. When you typically think of flow in the body, you generally think that it moves from high pressure to low pressure. Technically, it is from high energy to low energy. So there are some areas where the movement of blood can occur from low pressure to higher pressure. This is particularly true in a stenosis. So you really should think of the force moving the blood as not pressure but energy. So hydrostatic pressure is the pressure of just the column of blood. This is caused, we think of a person standing up, and the pressure in their feet will be higher than the pressure in their head, the blood pressure in their head, because of hydrostatic pressure. What we need to know about this is that hydrostatic pressure is measured in millimeters of mercury, so just like air pressure, and the formula for it is PGH, where G is the force of gravity, P is the density of the fluid, and H is the height. So the higher it is, the greater the pressure. And that also equals to about 32 millimeters of mercury per foot. Okay, so as we stand up, a 6 foot tall person will have 6 times 32 millimeters of mercury higher pressure in their feet than their head. Actually, that's not true. It's measured from the heart. So it's 32 millimeters of pressure from their heart to their feet, not from their head. Sorry about that. There's a few terms that you need to know and understand that are given here, and those are viscosity, resistance, capacitance, and compliance. First off, viscosity, that's just the thickness of the fluid, and we're talking about blood in the human body. And there's a lot of equations that have viscosity involved, but the fact is that any change in viscosity that's actually going to change the flow of blood in the body is far more before you see a change in the velocities on Doppler, it would kill a person. So we need to know what viscosity is. It's the thickness of the blood, but in practice it doesn't make any difference to the velocities that we read with our Doppler. Resistance, capacitance, and compliance are all kind of the same thing. Resistance is the resistance to the blood flow, and this is caused by frictional effects. But for the vascular exam, what you need to know is that resistance is controlled by the arterioles. Okay, so the arterioles control the resistance to flow in the body. Capacitance is the ability of the body to aid the heart in pumping blood, and by allowing the veins and arteries to expand a little bit. And so the greatest capacitance is the venous system, which goes from almost completely closed under a small amount of pressure to fully capacity when there's when the blood is sitting in the veins. So the capacitance of the veins is much greater than the arteries, and the ability for them to hold a large amount of blood is greater. That's kind of your capacitance. Compliance is, again, pliability of the vessels, and it's related to the stiffness. And so as a person has greater compliance in their arteries are able to peristalse and help pump the blood through the body, thus aiding the heart. You see this a lot in diabetics. They have poor compliance, and this ends up causing the blood flow to decrease because the heart is the only organ doing the work to pump the blood to the distal extremities. So compliance is stiffness of the arteries.